Okay, so this question is a proof question, okay, and hence you can see the word there, prove that. We've got these algebraic fractions, and you notice here there's 3 lines, right? 3 lines just means that it's identical, okay? So we want to show that this side is actually identical to this. It's not as if we need to solve it, right? It's not as if they're saying, look, work out what x is. They're not asking for that here, okay? It's not set up like an equation, okay? So we shouldn't be thinking this as an equation. If it was an equation, it would just be, they just have an equals sign there, wouldn't they? Okay? And you'd have to work out x. But we just need to show, look, this here is identical to this. And the way I go about this is, right, I'm quite formal. I will say, look, LHS, right? So LHS just means left-hand side, yeah? Left-hand side. And this is the left-hand side, isn't it? I'll just write that out again. 7x upon 2. Take away x minus 5 upon 3, plus then 3x plus 1 upon 5. Okay, now I won't worry about the right-hand side for a minute. I'll just look at the left-hand side because that's the one that's sort of all broken up, isn't it? It's all broken up. So let's see if we can sort of piece this together now, right? And see if we can get it to match the right-hand side. So what I'm going to do next is, I want to put these fractions together, okay? But in order to put the fractions together, I need to have a common denominator, don't I? Okay, because you can't add or subtract fractions when the denominators are different. So what we have to do is scale up each of these fractions. Okay, we need to scale them up. And, you know, to get a common multiple, right, on the bottom, common denominator, we need a multiple of each of these as common, right? And, you know, in the answer, we've got 30 there, so it's sort of pointing us to it. And if you think about it, 2 goes into 30, doesn't it? 3 goes into 30, 5 goes into 30. So we'll use 30. So what I'm going to do is I'm going to scale up each of these fractions, right? So I'm going to have 30 on each of them. Okay. So you notice now, I've written the denominators already because I want them all to be 30. There's a minus here and a plus here. So what I do then is, right, I look at this first fraction and I look at the bottom number, 2, and I ask myself, okay, what have I done to 2 to get to 30? Okay, I've scaled it up, haven't I? What have I multiplied 2 by to get 30? And then multiplied it by 15, haven't I? Multiplied it by 15. If I multiply the bottom by 15, I've got to multiply the top by 15 as well. Okay, so use your calculator. Okay, just to make sure we get this right. 7 times 15 is 105. So at the top, I'm going to write 105x. Okay, on the next one, a 3, it's been scaled up to 30. So I've made it 10 times bigger, yeah? Which means I need to make the top 10 times bigger. So that'll become 10x, won't it? And that would become 50, won't it? Or minus 50. I make it 10 times bigger. This here then, 5, I've changed that so I get to 30, scaled it up. So to get to 30, you've got to times it by 6, yeah? Times it by 6. So if I times the top by 6, then that'll become 18x. And then that will become 6. Make sure you times all of it by 6. Now when you've got a common denominator, of course then you can add and subtract, and we can put the whole thing over 30. Okay? But we have to be really careful. So we've got 105x to start with. Now be careful at this point because this says take away, yeah? And we've got to take away all of this, right? Because the minus is in front of the whole fraction. So we've taken away all of this. So what I do is I put a bracket round here, just to remember that. So I'm going to take away the 10x, minus 10x, and then I'm going to take away the minus 50. So 2 minuses then, yeah? It's like saying minus 1, isn't it? Outside the bracket here. Minus 1 times minus 50. 2 minuses make a plus. And then you've got plus 18x plus 6. So what you do then is, on the top, you've got 105x, take away 10x is 95x, plus 18x is 113x, and then 50 plus 6 is 56, all over 30. And straight away you might notice it's identical to the right-hand side. So what we just say then is this is equal, okay? Or you can even be posh and put 3 lines there, it's identical to the right-hand side. And we've proved that the left-hand side is equal to the right-hand side.